Hi folks, welcome back to the Algebra 2 series. Today we're looking at some complex examples where we're simplifying an expression. And you see here a series of numbers that are being added together. And we have the dot 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 located here, which says let's take this all the way to the 62nd term. And obviously that's going to mean a lot of things added together. But notice here also we've got that I to the first, I to the second, I to the third, I to the fourth, which tells us there's going to be some cycling going on. And of course the cycling we learned about in our previous example brought us to this diamond, this kind of baseball diamond looking thing where when we run over here to first base, that's like I to the first, second base is I to the second, which is -1, and then I to the third, which reduced down to I to the fourth comes out here at 1. And then if we were to continue going around this, we would end up this guy right over here, I to the first being the same as I to the fifth. So in other words, I to the first and I to the fifth take on the same value, the same as I squared and I to the sixth. So once again, we're looking for patterns that take us all the way around and then are able to essentially cancel out. In this case, I to the eighth being equal to I to the fourth, or 1. Well, let's go back to our example and see how that might help us here. Notice that in the first problem, -1 over I is something that we could rationalize. And if we multiplied the top and bottom by um, I, just in that fraction itself, we would get I squared in the denominator, which would be equal to -1. And that would cancel the -1 that's in the top. So essentially, we would cancel these two, and the first term would become I. In the second term, we have a 2, but the I squared in the denominator is just -1, so we can transfer that down as a -2. In the third case, we end up with -3, but remember that in the denominator, I cubed is the same as -I. And that negative will cancel the negative that is out front, producing 3 over I. And again, multiplying the top and the bottom by I, we would end up with 3I over -1. And that's going to turn out to be -3. So excuse me, -3I. And I'll continue that in just a minute. In the last case, the 4, we end up with +4 over I to the fourth, which means that this I to the fourth will then cancel out, producing just +4. Well, the neat part about this is as we connect our two terms here, we end up with -2 plus 4, or 2, and then I minus 3I, or -2, or minus 2I in that case. So what we see is that we have 2 minus 2I as the sum of the first 4 terms. I'm suspecting that you're going to get the same thing for the next 4 terms. But just to double check, let me do at least a few of them and show you how that works out. Notice that in the first case, way back over here, we ended up multiplying the top and bottom by I, which in turn produced an additional negative in the denominator. So very quickly we can see that our fifth term will be -5I over -1, or 5I. The next term, notice what happened here. The negative showed up in the bottom, and then we got 2 over -1, or -2. And again, the next term is I to the sixth, and there's a 6 in the numerator, so that's going to be -6. The next term came out to be a -3I, so we should get a -7I, and the last term was just a 4, and so we should come up with an 8. And as we see the pattern developing here, we see 2 minus 2I once again. And the question, of course, now is, well, how long will we get these 2 minus 2i's? Well, this goes all the way to 62, which is not divisible by 4. But if we move this down a bit, let's see if we can work this out. We're going to have 1 through 4, and then 5 through 8. And so all these are going to be divisible, and so 60 is the number we're looking for, because 60 is the one that we're looking to divide. In this case, it divides by 4. So the last 4 are going to be 57, 58, 59, 60, all those 4 terms grouping for the last one. And that is going to end up being, since this is 60 is our value here, and this guy is 4, 60 divided by 4 is 15. So we have 15 sets of 4 plus our 61st and our 62nd term. Now the 61st term is going to imitate what happened on the first term, which turned out to be way back over here. It turned out to be just the coefficient 1 and I. And so this is going to be 61I. And in the second case, this was added. That denominator on the 62 is going to make a negative, so it's going to be minus 62. When we put all of this together, we have 15 of our groupings. So 15, 2 minus 2i's, plus 61i minus, excuse me, let me rewrite that, 62. That becomes 30 minus 30i plus 61i minus 62. And it looks like the final answer then is negative 32 plus 31i. Gosh, I hope I did that right. That was crazy. But there you go. That's the sum of that entire series of numbers. Oh gosh, I just made a mess. Let me rewrite that one more time. That's that sum of the whole series of numbers together, negative 32 plus 31i. There you go. And just box that and run.